Everyone, we will solve this today's LeetCode problem. This is LeetCode medium subsets, right? So let's see what it is. So given an integer array nums of unique elements, return all possible subsets, the power set, okay, and the solution set must not contain duplicate with subsets. Return the solution in any order, okay. So we have to find the all possible subsets. So if you have seen the previous video, there we have also find the XOR value, sum of XOR all in all the subsets. So it's the same thing, it's same problem. Just we here we need to find where we need to return the all number of subsets, and there we have to return the sum of all XORs of all the subsets, right? So if you have this is the same this will be the same approach which we have seen in yesterday's video yesterday's video which we have seen in yesterday's videos. The two approaches two approaches will be applicable here. So if you have solved the previous problem, then this should also be solved by you, right? Right. So we will see that how we will solve this again, right? There's no issue. So see here 1 2 3 is given. So how many subsets are can be possible here? So here an empty subset can be possible, that I don't include any of the subset. Then I can choose one element. So 1 2 3, right? Then I can choose two elements. So 1 2 1 3 2 3. But I can't take again 2 1 and 2 3. Why? Because that will be duplicate subset, right? If I take 2 1 and 3 2 again, then this will be repeated, right? Because here it is written that it should not contain duplicate subsets, so that will be a duplicate subset, right? And if we try to take three elements, so 1 2 3 is possible. So this is how we need to find this. So how we will uh, find this, right? So if you see here, we are we are taking there we have choice of each and every element, right? Either I take this or not take this, right? If I don't take this, if I don't take this, then empty subset will be formed. If I take this one, if I don't take this two and don't take this three, there's really one form. If I don't take this one, if I take this two, if I don't take this three, then two will form. So this is how we will form. So let's see how it goes, right? So here we need to form a recursion tree, right? We will see in recursion that the first thing is that we will start from 1 to 3, right? So we have given 1 to 3. So let's see. The first thing is that either I can take one or not take one. So this is the 0 1 and 2 position. So I have two options: either I can take one or not, right? So first thing, we have two options. So either I take or not take. So first thing is I don't take, right? And the second thing is I will take it. So I have two options, right? I have two options: either I don't take it or either I take it, right? So if I don't take it, I will not uh, I will not I will not insert one in this here. It will should be empty. If I take it, this should be one, right? Now again I have two choices. What two choices? Either I can include either I can include this. So this is at a zeroth position. So this is at zeroth level. This is at zeroth level. Now this is at 1th level. So either I will sorry, this should be here. So either I take this first position, that is 2. So I have two other two options: either I can take this or not take this. So first thing, I don't take this. Second, I take this. So 2 will be inserted. Okay. Again I have two options here. If I go again, so again I have two options. What two options? Let's see. This and this. So this is at second position, which is this 3 wala. So this either I can take this or don't take this. The first thing is I don't take this. The second thing is I will take this, right? Okay, now this this part is confirmed. Now I will see for 2. So again I have 2 options here, right? The first option, either I can take this. Okay, let's uh, give some spaces here. Okay, and also here. So either I can take this or don't take this. If I take this, so it become, if I don't take this, so it becomes same as 2. So this will be 2. If I take this, then this will become 2 comma 3, right? Because I have taken, so I will insert now here. Now same goes for 1 also here. Same goes for 1 also. Okay, so again I have 2 options from here. Either I don't take this, the first part. This is one when zeroth index is included. Now I have to go with this recursion that at first position either I can include this 2 with this one, or either I will leave it. So if I don't take this, that will be again 1. If I take this, this will be 1 comma 2. Now again for this 1 comma 2, I have let's give some spaces again. uh, yeah, that will be much better. That is much better. So either at second position I include second in 1. So first thing is that I have 2 choices, that I will don't include and I will include. If I don't include, that is 1 only. If I include, that will become 1 comma 3. Again for this 1 2, again I have 2 options, right? Again I have 2 options. Either I can take this or don't take this. So 1 comma 2. If I don't take this, right, one, if I don't take this second third part, so this will be left to 1 comma 2. If I take this, then it will become 1 comma 2 comma 3, right? So if you observe here at the leaf part, I got all the values which we want without duplication. Let's see what it. Empty, 3, 2, 2 comma 3, 1, 1 comma 3, 1 comma 2, 1 comma 2 3. So if you match with this answer, you will find that we have an answer at the leaf position, which is at last. It means what? That one thing is confirmed, that our answer, our answer, that our subsets will be. We will get the our we will get our subsets at last at last position, uh, at last positions, right? At last positions or leaf nodes, right? This is confirmed, right? And if you see here, the same thing goes with the same thing goes with uh, yeah, if you see here the same thing, uh, uh, you will see here the number of counts: 1 2 3 4 5 6 7 8. It means what it is. If you see the number of subsets, the number of subsets the number of subsets subsets count is 2 to the power n. What is n? The total number of elements, where n is count of elements present in array, right? So 2 to the power n is what? N is 3. So 2 to the power 3 is 8. So we have got 8 subsets, right? So this is how we will solve this. So how we will iterate in this? How we will find this recursion part, and how will this? So first thing is that I have. So what will the approach here? So approach would be that I have 2 options for each and every element. Every element, either I include or exclude it, right? Either I can include or exclude it. So what we will do? We will start from every point, and either I include or exclude it. I will iterate again and again to our recursion stack, right? So what will the base condition? So when we I so what we will do? We will start. So this will be the function, this will be the function. And if you see here, either I can take this, right, or don't take this. So 0, then the number which we include, and the number which we include, and the index part. So this is the index, and the the array vector part which is need to be stored, right. This is the vector part or array part which need to be stored. So here in this, either I include this 0 or in not. So if I include this, so it will become 1, and if I don't include this, it will again becomes 1, and this will be empty. But if I include it, this will becomes f1, but this 0 is included here, so it means 1 should be here, 1 should be here, right. The 1th index should be here, the one part, this one is should be present here. Now again for the same thing, either I have two choices for every element. So if i if I include this, so it means for second element I have to again two choices. For second part, either I disclude it, I don't include it, so it will be again empty. But if I include, so that will be 2, because I included the second part. uh, so the first element is here. So if I don't include this, so this will be 1. But if I include it, so this will be 2, because this one at index is at 2 position. So the one position will give me the value, either include this or not, right. The same thing goes with here. And this is how we will approach this. So what will be the base condition where we need to return it? So the base condition would be, so what we are incrementing, what are the changes we are doing. Index is changing, index is always increasing again and again. Either include this or not, I'm increasing the index value. It means if my index is goes out of bound, it means if I is less than equals to n, then we need to return from here. But if you see, I got my answers at last value only. I got my subsets, every subset at last value. It means whenever I hit a base case, I need we get a subset which I will store in this array, right? Which I have stored in this array. So I will store this subset, this array subset, in my final answer. That would be the 2D array, right? So if the base condition hits, then we definitely got a subset, definitely got a subset. So we will store that and return from there, right. We will store that and return from there. So this is how we will solve this problem, right. Because at last position we got a subset, each and every subset I got at last position. So I need to, whenever I get a hit of the base condition, I will store that subset and return from there. So this is how we will solve the problem, this possible subsets. So if you see, here the nums dot length is 2 to the power 10, and for each and every possible for each elements I have two options. So it means there will be 2 to the power and time of complexity. And for storing this subset, I need an extra array for every point. So that will be again into n. So that will be left to 2 to the power 10 is 1024 something, and this is 10. So it is not much time of complexity. So this can be possible, right. We will come to this, but let's start implementation so that you can easily understand it, right. So let's just make a variable, make a initialize the 2D vector for storing our subsets, right. And start solving this. Start We will start from where, 0th part. And also I need to store at every step an array for a particular subset, right. So let's take at temp, and we will pass this temp to here, right. Okay. Now comes to this solve function. So this is index and this is this temp value. Okay, so we will pass this by reference, and we will uh, why we are passing this by reference, because it when we insert this one, right, when we insert this one, and after this values when we go, we will backtrack this. So this one would be pop out from this, so that will become this one. uh, so what does it mean, that if suppose f22 is here, right, and when I go to this f22, and when I try to include this or exclude this, so this f, so either I have two options, either I can include this to the second index, the third index, right, the second index, sorry, 0 1 2. So either I can include this or exclude this. If I don't include this, that will left out with 2, but if I include this, it will become 2 2 comma 3, right. But when I hit the conditions after this I will hit the condition, that will be go out of bound. So when I reverse back, when I go from this to is this parent, I will pop out this elements, the last element which we have inserted, that is 3. So that this will become f22, and I can go to any other tree, because from here I need to go to here, or here, or here, right. So I need to backtrack this, because this 3 inserted for this part only now, but for here in this array there should not be 3, so this should be backtrack. But if I simply pass this array to here, so that will take an extra time of complexity, because that will take an extra time of complexity, of course, right. So which we don't afford, because it makes a copy if you pass it by values, not by pass by reference. So that's why I pass by reference here. That's why I pass by reference here. If you pass by only value, so that will we also work, but that's take an extra complexity work, because it copies when you pass by values. So we will pass it by reference, right. So what we need to do, we will either include it or exclude it. So if you include it, so first thing is I will include it, so I will just push back the current nums in my temp, and I will increment the index, and also the same thing, right. So I will include it, and for excluding it, so I need to pop back for backtracking. Just I have told you why, because I need I because I am passing by reference, so I am passing by reference, so it automatically it will not update automatically whether so that I need to pop back the last element which we have inserted here, because it will not automatically delete the last element. So I need to uh, pop back this for backtracking purpose, right. So this is for including. Now I will pop back this last element which we have inserted. Now I will only this is for excluding part, that I have not included my this current element to my subset, and I will just call this I plus 1 again, right. So see, for the current element I have two options, either I include this, or I will add exclude it. For exclusion, that's why I have pop back, because I have included beforehand. So this is for excluding, right. Okay, now when this will recursion will end, I have told you that this I plus 1 is only changing here, this I plus 1 is only changing. So if I greater than equals to n is the n is the okay, n is the num size, right. So n is the num size, so I need to pass this also. So let's pass this, n is the num size, so I need to pass this. So if I pass this n from here, so this will be here, and this should be also included here, or I can also make it global, but just let pass this. So if I less than equals to n, it means I hit a base case. So I need to push my current temp value in my answer, because that will give me a subset, but this will be a possible subset, and I will just return from here this temp is a possible subset, right. And we have seen that at last position I definitely got a subset. So this is the last position we got, and this should be a subset, so I will include in my answer. And finally after this I will just return answer here. from him, right? So this is how we will solve this problem. Let's run this and see whether we have successfully done this or not. Something. Okay, we haven't passed nums. Oh, okay, okay. So this should not be passed if I am passing this nums. So this should not be passed, right? Let's pass this nums vector, and always try to pass by reference, because if you pass by values, it will make a copy again and again when you will pass it. So I will always try to pass it by reference, so it will not uh, pass by it will not take any extra space, right? That should be always remembered uh, by everyone, right? Let's run this. Sorry. Why I'm doing this? Why I'm doing this? And this should be an, I think, now this should work. Definitely it should work. Again. Okay. Commented out. Now this should work. Yeah, we have successfully passed the sample case. Let's submit it. I hope that will be not give any error. Yeah, we have passed this question. So what is the time complexity? If you see here, we have two choices for each and every element. So that will be definitely true to the power n, right? And we are passing this temp value. We are taking this extra temp, which can be of value of n 1 to 3 whole n. So that will be n into to the power n, definitely. So yeah, that will be past this, and the space complexity is, so we have an auxiliary extract space O of to the O of n, of course, right? So this will be O of n overall time complexity, and the space complexity will be. So for the another approach, what it be? So for the another approach, there will be iterative approach. That will be a iterative approach. So how will solve this iteratively? So yesterday I also told you that there is a bit manipulation, bit manipulation. So if you observe this, I have told you the number of subsets is what? The subsets, number of subsets is 2 to the power n, right? So it means if you have 3 elements, it means it should be have 8, and this 8 means 0, 1, 2, 3, 4, 5, 6, 7, 8. So if you see here, if you see its binary representation 0, then 0 1, 0 1, right? And then what, 1 0, then 1 1, then 1 0 0, right? So this is how this goes. This is how this will go. And for again for 5, this would be 1 0 1. This 6 would be 1 1 0. Like this will go, right? Just write, I'm writing it to show you something. Okay, this 8 should be not here, because there are 8 elements already here. 0 1 2 3 4 6 7, right? So if you see here, this 0 part is indicating the empty subset. Why I'm telling this? So if you see here, we have all the options which we need here. Why? If you see on the one side, every bit set bit, observe observe the set bit and each element's binary representation. So if you observe here, this zero will what this zero representing, that I will not take any of the elements. So this is representing empty subset. What this 0 1 representing, that I will include only the first element, because in binary representation, in binary representation in binary representation, we see index from right to left, and in array we see index from left to right, right? So that's why I'm saying from right to left that this is the zeroth part. So at 0 this is 1 here, so this is 1 here, it means I will include 1, right? I will include this one here, right? It means I will include this one. So if there is 0, it means, so this is for 1 to 3 only, so all the part are 0 here, it is also 0. If you see here, this is also 0, so this is also 0 here. So it means I don't include zeroth part, I will include only one. So it means if I include one, it means the first index should be included. So I got the first subset. Okay. Same thing goes for this. So this is zeroth index. So I will don't include one. This is oneth index is set bit. It means I will include two. So that will include it too. Again for the third, this is one comma one. This is one one. It means I need to include the first part because that will be one. I need to include the second part, that will be 2. Same goes for this. Now this zeroth index, I will don't include 1. Zeroth, I don't include 2. Okay, and this is the third index, that is I include 3. So that will give us 3 here. Again for 101, the first index is 1, so I will include this one because it is set bit. Second is not a set bit, so I will don't include 2 here. The third is set bit, it means the third should be included. So this is how, if you see, I'm getting all the subsets from 0 to 7 if I follow the binary representation here, right? So this is 100, again 0 is not included, I will not include 1. The second is set bit, so I will include 2. The third is set bit, it will include 3, and this is all has 1, so I will include 1 2 3. If you see this here, I got all subsets, 8 subsets here by following this binary representation. So if you here see what we are doing, we are iterating. We will iterate from 0 to 2 to the power, and this should be excluded, right? This should be excluded, and check for check binary check in their binary representation that which at which position it has a set bit, and then I will include that position in my array, that position element in from my array, right? That's what that was we were doing. This is 101 here, so this one is at 0 index, so I will include this one. This 0 is not set bit, so I will not include this 2. The third part is the one is included here in the third, so I will third include this. So this will, I got 1 3, so that was I included. So for each and every element I will check their binary representation, that which position has a set bit. If the position is set bit, I will include that position element from my array also, right? So how will we do this? So let's take an example of 5 only, and this is 101. So here in this 101, for checking the set bit, what do we use? We use AND operation. We use AND operation. Why? If you observe, 1 and 1 gives you 1. 1 and 1 gives you 1, but 0 and 1 gives you 0. Also 1 and 0 gives you also 0. So it means there should, if there is 1 present, so it means there, if there is 1 present, it will gives you 1 only. So what we will check, and if there is a 0 present, this will give you 0. We don't need this. And so that's why we use AND operation to check this. But if you take odd, so if I 1 is present here, so it will no matter that how which what the value is present at this first part 10 or 01, it will always give 1. So that's why we use AND operation to check whether this bit is set or not, right? So what we will do, we will check this for 5 that which subset will represent, and we will move in this index. So and what we'll do, we will move in this index from 0 to n, from 0 to n minus 1. Of course this should be excluded, right? So what we'll do, we will move to every index. So what we'll do, we will check for this 101, that this 101, and okay, this is 0. It means what it means, it means 2 to the power 0. What does that mean? At 101 and 0, what it will give, it will give 0, right? Again for 101, and the second position we will check that whether the second position is uh, okay, this should be 1, sorry, this should be 1. So this should need, this is set a bit, so I will include this. Again for second position, 2 to the power 1, that is 101 and 10. This is the second bit now, this is the second bit I need to check. So this should be 1, the second position. See, I'm telling second position, but that's indexing is from 01, right? So don't be confused. I'm telling second position, but the indexing is from 0, starting from 0, right? It starts from 0, right? So don't be confused, please, right? So the position which is at the second, which is as the 1th index, okay, this which is at the 1th index should be a shed bit. So if I check this with, this will give me what, 0. Of course it will give me 0, right? Again for 101, and for the for the second index, that will be again what, I need to set the second index. So if I set the second index, that will give me 100. So if the second index, you will see this 1 and this one is a set bit, so it will give me 1, so I will include this, right? So and this is 2 to the power 2, okay, right? And one thing, and I will tell you, the bits thing, bits properties, or bits properties, right? This is one, and if you left shift, so this is left shift, this is left shift, and this is right shift. So if you shift it by any element, suppose j, so it becomes 2 to the power j. This one means here is the one binary representation is 01, right? So if you shift it by j, it means if you shift it by 2, it means this one will left shift by 2 here, right? It will be left shift by 2 here, understood? If you left shift by 2, it will left shift by 2, it means it will goes to where, 100. One will be present, one at starting, one is present here, but after shifting to, it will move to 2 position in the left side. So what is does it represent? It represents 2 to the power 2. It's represent 2 to the power 2. It means 1 less than 2 represent 2 to the power 2. That's what I've written. If you see 1 less than j, it represents 2 to the power into j, right? It does represent this simply, understood? So if you see left shift, it means 2 to the power j. So can I write for, instead of 2 to the power 0, 2 to the power 1, can I write this, uh, that I will left shift with this index? Can I write this instead of 2 to the power 0, 2 to the power 1, 2 to the power 2? This is indexing a 0, 1, 2. So I can write this one left shift I, right? This will give me the same result, 1, 1, 0. So that's why that was we will use here, right? So this is some bits properties you need to remember. So this is how we will form a subset. This is how we will form a subset. So for what we are checking, we will go to the every representation from 0 to 7, and we will check which position is which position of this binary representation is set bit, and I will include that in my answer. And after completing or binary representation of a particular element, I will insert this subset in my answer simply. Let's try to implement this. You will really understand better, right? So let's remove this and also this. Okay, let's include this here. Let's include this here. Now, the first thing what we need to do, we will iterate. If you see what first thing what we will iterate from 0 to power n and check the binary representation. So first thing we will iterate 0 to 2 to the power n. So either you like type this, or I have just told you that this is similar to this and this is similar to this. So I can write one less. I can write, or I can also write one less than a, right. I can also write this an I plus plus. So now this is the value which we got, this is the value. So this is the ith element. Now I will check, for each and every element that which bit is set for this, and I will include this. So for that, what I will do, I will check for each and every index. For I will check 0, 1, 2, that which element is the set bit for this. I will include all the elements which element is set bit by setting up that bit at that position. So see, for this first for the 0th index, I have set at the 0th part set. For the first index, I have set at the first part set. For the second, I have set at the first second part set bit, right? So I will set it like this. This is the value, and I will check that after this is set bit or not. If it is a set bit, I will include in my answer. So for including, I need to take a temp value. So this should be the temp here, which I will include here. So I will insert this in my temp, this current index answer. Okay. So for this particular value, I will iterated in all and inserted all the values which as a set bit. After this, I need to store this temp. So I will store this in my temp. I got a particular subset after this, right? What is one less about it? It is same as 2 to the power j for setting up, for setting for setting for set the bit at specific at the jth position, right? And this is I return j. So this is how we will find the subsets. Let's run this. uh, okay, I have not included any. Yeah, we have successfully passed the sample case. Let's submit it. Yeah, we passed. So what the time complexity and space complexity? So the time complexity is O of, we are moving from 0 to 2 to the power n. This one represents 2 to the power n. So we are moving from 0 to 2 n, so 2 to the power n, and for each and every element we are moving from 0 to 1. So that will be O of 2 to the power n into n, right? And what the space complexity? So that will be, we are not, we are taking an extra space for returning answer, and this is an extra space which is inside this. So I if you see this, if you try to if we don't normally we uh, don't take extra spaces for the returning answer. So that will be O of 2 to the power n again, to store all the elements, and for storing again for each and everyone, that will be again O of n, right? Because we, for storing all the elements, we need 2 to the power n elements. So that will be storing an answer. So that will be space of time complexity of O of 2 to the power n, right? Same thing goes for here. Same thing goes for here, because we are taking an extra space for returning answer, so that will be again 2 to the power n, and 2 and 2, right? Because if we are including result as an extra space, that's why 2 to the power n into n. Otherwise, that will be O of n again, right? So yeah, this is how we will solve this. Thank you so much. Bye bye.